All right. Today we're going to talk about the chain rule. The chain rule is going to be used in specific instances. Before we get to actually using the chain rule, we need vocabulary. The chain rule is going to be used for something called a composite function. Anybody know what a composite function is? That's okay if we don't know.
Composite function?
Yeah, do you know what a composite function is? Okay. A composite function is a combination of two or more functions. Carmela? Where it appears there are functions sorry, give me a second. Inside of, or composed with, or substituted in another function. Am I off screen? I'm about to be though, right? So a composite function is a function inside of another function. We put two functions together to make one. So for example, this is what an example and a non-example would look like. Let's start with the non-example. The non-example that we're going to use before I do, you do, 3x to the 6th. We have a normal term where we have a coefficient, a variable, and an exponent. This is, can I scroll down?
Yeah.
Right there, good?
Yeah.
Okay. So this is a regular function where we just have a coefficient, a variable, and an exponent. Nothing else weird about it. This is an example of a composite function. 3 times the quantity of x to the 4th plus 7 raised to the 6th power. This is a composite function because instead of just this plain old x, I have x to the 4th plus 7 substituted in where x was. Our first function is inside, which is x to the 4th plus 7. And our second function is on the outside, which is 3 as the coefficient and 6 as the exponent. So this is a composite function because there's one thing inside of another. Kind of get it? Okay. Again, this is not a composite because we just have a plain old variable with an exponent. Here, we have multiple terms inside where the variable was with the exponent and the coefficient. Okay? So far, so good? Do we understand what a composite function is? If you don't, see me in office hours. The chain rule. So this is what we're talking about today. The chain rule is the derivative rule. Am I off screen? Used when a function appears as a composition. Okay. So let's take the simple one. F of x is equal to 3x to the 6th. Okay? If we took the derivative, all we had to use here was the power rule. That's it, just the power rule. However, if we took our other example, I have too many terms to be able to do the power rule. And it would take you an extremely long time to multiply 6 different binomials. So we don't do that in calculus because we have a shorter way to do that. That's called the chain rule. So here we would need the chain rule and the power rule. We need the chain rule and the power rule. Brian? From this point on, 99% of the time, we're gonna have to use the power rule. So this is why we spent a lot of time on it, to make sure we understand it. And if you still don't understand it, you have to see me in office hours. I cannot spend another week and a half on power rule. Okay? Can I scroll down? Yes, no, maybe so. Up, up. You good? Okay. They already got this or no? If I give it to Carmela. Okay. All right. So, let's start with the formula. Oh, I'm off screen. So we have the formula for the power rule already. A lot of you have it memorized. Good for you. Yes, I have it memorized too. The chain rule is as follows. So if I have a function, h of x, that is composed of two functions, u and v, so we have a full function. I'm going to split that group up. Sorry, I lost my train of thought because we have immature kids. Okay. We have a regular function that is composed of two different functions. U with the parentheses will be called our outside function because it is outside the parentheses. It's outside our function notation. And v of x will be our inside function because it's inside of u. The formula for this is as follows. So the derivative of the whole composition is v prime. So this is the derivative. It's not 1. It is not a 1. Times the quantity u prime. Oops, I used a different color, my bad. Of the original function. So this is a derivative, and this is a derivative. And this is the original v. Original. Yep. That good? Am I going too fast? A little bit? Okay. Can I go down a little? Can I go right there? Yes, no? What about there? Okay. All right. So before we start to use this formula, we have steps on how to use it. Okay, so steps. While I'm writing out the steps, I'm going to use our example, the j of x is equal to 3x to the 4th plus 7 raised to the 6th power. Okay? I'm going to use this example as we work through the steps. Capiche? Thank you. Okay. Number 1. You need to find and label, can't spell today, label, u. Again, which is our outside function. So in this case, u is going to be the 3 and the 6. U is 3 times some quantity, 6. Keep this blank. You want to keep this blank as a placeholder so when we get to it, you know what to put inside of here. Keep this blank. Don't put an X, don't put an F, don't put a Y. Keep it blank. What's up? Which one? Find and label. Christian? Am I going too fast? Okay. Next step, find and label. What do we think? Find and label V, which is our inside function. What is the inside function? What is inside the parentheses? X to the 4th plus 7. That is inside the parentheses. So outside again is the coefficient and exponent out there. And inside is what is being raised to that exponent. Now, level 2, this is level 2. All you're going to have for level 2 are problems like these. You're not going to have square roots, cubed roots. You're not going to have negative exponents. That's going to be level 3, okay? We're going to work on level 2 tomorrow, and then next week we'll start on level 3. There is no assessment this week, so don't worry. No exit ticket, no entry ticket, no quiz.
Why not?
Because we only have 2 days.
Oh.
All right, step 3 is to calculate u prime. So we need, can I go down? We're going to calculate u prime. Remember, this means that we are using the power rule to find the derivative. So I have u prime. I'm going to use my power rule. Why am I using this? The power rule says that I can take my coefficient and my exponent, and what do I do to them? Multiply. Yes, you multiply the coefficient and exponent. And then you subtract 1 from the exponent. So u prime is 18 times some quantity raised to the 5th power. Any questions on that? All I'm doing is using the power rule. Yeah. Any questions so far? Okay. Step 4. Calculate v prime. Remember, this is the derivative. We know that v is x to the 4th plus 7. So v prime will be equal to, using the power rule, 1 times 4, x to the 4 minus 1, plus 0, which means that it is just 4x cubed. Any questions on how I got any of that? Are we sure? Are we sure? Okay. Then, since there are no questions, we'll move on to our last step, which is to write the final derivative. In the form of v prime u prime of v. So I have j prime of x. Remember, use your notation. Is equal to v prime, and here's v prime. Do you guys see that? 4x plus, or 4x cubed. U prime is this right here. So we have 4x cubed times the quantity of 18 times the quantity of something raised to the 5th power. That's u prime. And then, last but not least, you put in the original v. This is why it's very important to label all of your steps correctly, so you know how to put it in the formula. And I know I color-coded it. You may not be able to color-code it, but keep in mind that I put this on YouTube, so you can go and color them if you need to. Huh? Sure. Go right ahead. I've got 8 subscribers.
Is that a 2 or a 1?
That's a J. Questions? So you see I put v prime, which is green, a magenta u prime, and a pink v. So it's going to be derivative, original. Derivative, original. Derivative, original. When you're done copying that down, take out your do now and flip over. We have examples. Do you need to move up, Kimberly? Good? Thank you. Good? Anybody else still writing down? Gentlemen in the back? Good? Okay, girls over there? Good? Okay. Alright, example 1. Example 1, we have f of x is equal to 4 times the quantity of 5x to the 4th plus 9x squared plus 2 all cubed. Okay? Alright, let's go through the steps. Somebody tell me what my first step is. Find u. What is u then? 4 something 3. Good. Oops, let me label it. I'm just going to put equal u. Okay? Are we good with me doing it in different colors so you know the steps? Okay. Step 2. What is step 2? Find v. So what's v? Very good. Questions so far? Am I going too fast? Yeah? A little bit or a lot of it? Okay. Do you understand so far where these things came from? I think because you went to the bathroom, right? Here. I don't know which ones you have and which ones you don't. Okay. Step 3. What's step 3? Find u prime. So how do I find u prime? By 6. Mm-hmm. And then? Oops. Very good. 12 something squared.
Isn't it minus 9x squared?
Is it minus 9x squared? It is. Thank you. Okay. All right, next step. What is the next step? Is that it? Find v prime. How do we do that? Keep going, Jaira. You're done? Okay. Let me know when you are.
5 by the exponent.
Okay.
X, and then 4 minus 1.
Mm-hmm.
And then same thing with 9. 9 times 2. 2 minus 1. The 2 becomes plus 0. And then you combine those and that's your equal.
Very good. Questions so far? All right, Jahira, you ready to put it together?
It's going to be x equals x squared to the third minus d squared. And then Twelve, and then original p side parentheses.
However, this would only get you 1.5. Why would this get Jahira only a 1.5? Very good. Christian said the prime. You forgot the prime.
Sorry.
Notation, notation, notation. Questions? Wake up, wake up, wake up. Are there any questions? Are you sure? Okay, we have 5, 10, 15, 20 minutes. This is what I'm going to do. I'm going to give you about 15 minutes to work in your groups on the remaining 3 problems. And then I'm going to pull people's papers and put them under here to see what the answers are. Capiche?
Yes.
All right.